We are here to help you speed up your transformation, enable you to innovate, and deliver solutions with real business value. If you need a partner to help execute your digital transformation plan, we got this.
StratPoint rallies Filipino pride. We develop homegrown talent and inspire them to contribute to technology development in the Philippines. And from there, make a difference in the whole world. We want to go beyond technology and business. At the end of the day, what matters is how StratPoint shape tech leaders who are conquering global challenges and igniting change for the better.
Our next speaker will show how to deploy your own mobile-ready AI models. He'll share how to solve the hurdles between cross-language, Python, Kotlin, and Swift, using readily available mobile frameworks and your own custom-trained models. Our speaker oversees AI, ML and emerging technology projects at StratPoint. Please give a round of applause to Capability Head of AI and Technical Manager of StratPoint Technologies, Mr. Adrian Kayako.
Hello, good afternoon, everyone. Hopefully, you had a long journey of learning from yesterday's session and this morning. So, allow me to share my screen. And while I'm doing that, I'm trying to get to know you guys and gals in the audience. So, let me publish this poll first. Yan. Have, are you seeing the poll? So I'll give time a few seconds to a minute. Feel, please feel free to answer. Don't worry. I'm using this data later on. Joke. I'm just using this data to get to know you guys. So I'll know how to explain or if I can dig deeper into some of the concepts. But for this afternoon, I promise you that I will stay on the higher level side of my explanations, and I'll just guide you throughout our journey. And I prepared the slides for everybody to follow. Okay, a few more seconds. Okay. Thank you everyone for answering the poll. So the precinct is now closed. Um, so good afternoon everyone. Again, I'm Adrian Kayako. I'm the head of AI engineering in StratPoint. This afternoon, we will actually talk about four parts. So one, I'll reintroduce to you AI in mobile. Hopefully, we've been using AI throughout our mobile applications now. And afterwards, we'll talk about some benefits or even challenges when we are deploying AI models in mobile, and what are some insights and lessons we've learned from developing and supporting cross-language platforms like Android and iOS. Lastly, I'll give you some hints and hopefully also show you some lessons we've learned during our whole endeavor. So, without further ado, let's kick it off. Sorry. So, some general classifications or categories for mobile applications. I am sure we've known this and we've seen this because we've been using these applications throughout. But I've only highlighted a few of this. So I'd like to ask everyone to type in chat, what do you think are, let's say, or what is AI within these apps? Do you have any idea? Can you type in chat? What what do you think are AI here? Let's say one. I'll take the answer now. Face recognition. That's one. So what other AI do you think are in these applications that belong to these categories? Virtual assistants, social networking might be recommendation, right? Matching, recommendation algorithms. What else? Productivity. Oh, another one, voice recognition, right? So uh, in the space of AI, we might have not noticed it, but it's really now within our hands, literally within our hands, within our mobile devices. But for today, for this afternoon's talk, also, I'd like us to focus on a general category in utilities and social networking that actually have or use images or our camera. So one use case really is object detection and recognition, right? So under this, we'll say I'll focus or narrow our path to two. One is facial recognition or object detection, and the other is optical character recognition or OCR, as um, commonly we hear in the or see in the internet. And lastly, I guess this is one of the more viral applications we've seen, the use of AI, right? Image filters and style transfer. Who here has used those um, aging applications or the, what do you call this? What do I look like? So it falls under loose term of image filters and or category of image filters and style transfer, right? So we've seen it from Snapchat, from the filters in Facebook and other social network, and even the applications that make us dance, right? So um, so these are AI algorithms already in the palm of our hands, and actually developers or teams are actually deploying now AI in our hands. So Just let's take a step back. And I've actually narrowed it down into two parts. So this is just also my interpretation and summarization of some of the benefits we've seen so far when we want to deploy or deploy AI models in the edge or offline. One really, as developers, right, is really the reduced cost of inference. What do I mean by that? One is when we reduce latency, meaning the inference or really, right, the model is processing within our mobile devices, we should expect sub-second responses, right? Next is actually bandwidth consumption because the AI model is right at our hands or in the mobile device. No internet is needed. Therefore, we are saving on bandwidth consumption. And basically, the last thing is the cloud infrastructure cost savings. Why? Now, if we're talking about AI models within your mobile applications, with the number of users we have with our mobile applications, our cost might exponentially grow. Or really, the inference or the number of inferences will actually grow with the increase of the number of users. So deploying models to the edge or to mobile devices will actually reduce that cost. And the general second category I'd like to summarize for everybody is or the operational availability and the flexibility of really deploying AI on the edge. Why? Because it's really offline, meaning we are not limited to use cases that need infrastructure, right? So if we have the model within our hands, within our mobile phones, we are actually empowered to solve use cases that really are on the field and don't have infrastructures. Second to that is actually we are building for customized tasks and use cases, right? We are fine tuning the model to solve one task at a time, and it's really the practical aspect of that solution. And lastly, real time output. With the low latency, the customized task, we will now be equipped with real time outputs and solutions, even predictions, right, within our hands. Next, with the benefits will actually come challenges, right? So this comes with everything we or every problem that we are trying to solve. One of the challenges that we've seen so far is actually how do we update and maintain our models, right? How do we get the feedback? So we need to build in some features or functions within the mobile applications that ship or transfer live data from the mobile device or sync it later on to back to an infrastructure that our AI engineers, data scientists can also use to iterate again our models. And how do we actually also deliver those updates? Have you heard about content delivery networks? Just type one in chat if ever if you've heard about it. But delivery networks are cloud infrastructures. Mainly, it's uh, a way to actually deploy or deliver large chunks of files to geolocated spaces, right? It's really how do you deliver or cache content to your user base. So within the Philippines, if all your users are within the Philippines or in the Asia Pacific region, so some of your models should be cached within those local hotspots, right? So that's one challenge that we also need to answer. But later on, I'll deep dive on it, depending on the use case or the project you are trying to solve, right? Now, hardware diversity. With the ecosystem of both platforms, the big platforms, the two, right? I'll just mention two for Android and the iOS platforms. One challenge is the framework compatibility. So as a developer, as an engineer, what technology, what tech stack we I'm sorry, we will be using. Lastly, in the real world, sadly, or this is also a true fact, depending on the hardware or the parameters we have physically within our devices, performance really will vary. So I'm talking about inferencing or even the time it takes to finish an inference, right? So with the more powerful and higher end devices, that will be most probably negligible. but for low powered and budget devices, that will also need to be considered, right? If we're trying to solve a use case that also incorporate that aspect of the mobile device. Lastly, as developers, there will be complexities within the whole development life cycle. So, have you heard about DevOps? Have you heard about MLOps? Now, once you integrate also a mobile within that, or even just the web part of it, more so with involving mobile with it. So, therefore, we really need to actually strategize how do we deploy our models or even applications. Lastly is actually compatibility support. Why you'll see this throughout our session this afternoon, because this is mainly due to the fragmentation of the ecosystem, right? Even the Android ecosystem or even the iOS has some iOS platform has some um, fragmentation, but more so is actually experienced within the Android ecosystem, meaning even different brands will have different implementations of the same Android OS, right? So, um, just to summarize, these are some of the challenges that we've actually seen so far within the developing AI for the mobile. So, let's take a step back. Before I move on here, can I ask everybody, what's your daily poison? Joe, what's your daily driver? What's your daily mobile device? I just get everybody's survey for what do you use. Is answering. Nobody has a Symbian phone. Do you know about Symbian phones? You can type in chat who knows about Symbian phones. So, as you might have known, I've also I grew up with those Symbian phones, right? So not to showcase my age, but I've actually known the transition from the Symbian phones to the first versions of iOS. Later on, Android. Okay, but yeah, thanks everybody for answering the poll. Um, So let me give you an oversight. What do we mean really by cross-language solutions? So when we're developing for AI, we have usually two choices, right? A tech stack, Python and R. But most of the code out there really is in Python. And we want to deploy that model to the Android platform and the iOS platform, right? So we're talking about mainly the three languages, three programming languages, mainly Python, Kotlin, and Swift. I've chosen this for our session because we're talking about mainly native. Um, Sorry for those who want Java, but I've ruled out Java for now because later on I'll give an example. We can still support Java, but most examples now are in Kotlin. Okay, so how do we actually make models work for both platforms? Who here has seen this too? Hopefully, a few of you are familiar with these two high compute programming frameworks, right? So I've seen some thumbs up, right? So who here has used the Onyx library or framework? Therefore, I'd like everybody to introduce to everyone Onyx. Really, what is Onyx? It's actually a what cross-platform compute library that allows us to morph our models, our code in models from the base TensorFlow or PyTorch libraries to a usable version for mobile. So I've excluded here the other versions like JavaScript. There is a TensorFlow JavaScript for uh, web models, right? For web AI models. But we're focused now on the mobile side of things. For Android specifically, we have used or explored these two, the TensorFlow Lite and the PyTorch Lite. Lastly, for the iOS side, right? You've seen and heard about Core ML. They have a long list of supported algorithms and neural networks out there already. that, but if we want to customize or train our own models, we might have to use these and integrate these tech stack within our platforms, right? So, and that's true to our case. We've actually utilized these um, frameworks and libraries. Okay, so as let's also take another step back. I'll try to explain this on a higher level, but for those who know these jargons, or really, these are components within our model, right? The neural networks. Some of the issues we've actually encountered are version incompatibilities, meaning one layer is not supported by another platform or is has not support from the Onyx layer itself. Therefore, work is needed within that bridging, within the translation layer. Next is actually parameter dimensions. Um, if you've uh, dug a bit within the model, right, and within the, let's say, a Python code, within the Keras layer, or even in the neural network Python code, you will see expected parameters here, there, sizes, more so with images, right? So there is an expected input, an image size or resolution, and there are expected outputs. But what if during that translation, everything is flattened from an n by m, or let's say a 1080p picture? Yeah, that's 10,000, right? 10,000 by 7,000, 700, 1,000 by 700 plus pixels. It now gets squashed into a one-dimensional vector of what? A few thousand by one vector, right? So that's also a challenge. But again, we have some tools to actually solve it. Now, within the deployments, that one one-dimensional vector, right, needs to be interpreted. So, don't worry, guys. This is not a math quiz. Who here is familiar with this equation? So, for classification problems or object detection, this is seen most probably at the last layer of the inference, right? This is what? A softmax layer. This layer actually tells us what our classes or what our inference classes are, right? The problem we saw was actually there is no native support for softmax. So comes in an LLM, and voila, you have a function that is also mathematically proven to actually be, or to have the same yield as the softmax function within Python, but now it's really a math equation, right? So who here has come into a problem like this? It will depend really on your use case and what algorithm you use, but there may be code that is really lost in translation. Therefore, you need to write it back. Okay? So, with that said, um, I'd like us to focus more on our journey, really, what helped us and what allowed one or two engineers, what empowered us to actually solve this use case. What? So one, we need to understand really the feature and the process. Coming from a user story, right? From a business rule, coming from a feedback from the client that we want to solve, or the problem breakdown itself, we need to understand what the feature is or the problem and how do we actually break down the process. So in terms of computer vision tasks, really, we can integrate multiple layers of models. One, right, the first layer could be a classification problem. Next would be what? An OCR layer problem, since we need to extract information. The next layer would be what? Processing optimization to have more reliable outputs. So the combinations of our solution utilizing models on the edge is actually multitudes, right? The trade-offs, though, is the compute or the time of inference. But if it's negligible and our inference time is still below a second or sub-second, right? the human eyes or even the human perception now um, can still adapt to it, meaning it's not yet slow. Therefore, our solutions or our model layers should be dependent also on that trade-off. Next is what? Really, it's utilizing LLMs now. To name a few, have you used it, right? Within um, there are big APIs out there like ChatGPT, Bard, even right. Copilot is powered by GPT 3.5 or 4.0. But what is it to us as engineers, as developers? It allows us to actually type and try code that are foreign or alien to us. Meaning, me as a not yet a fully fledged full stack engineer, I can now try and see if I can run this Kotlin code. Well, I have this code. Can I run it and deploy my model test? Because what I know is really just Python. But because of the LLMs nowadays, I can try to deploy an Android application and an iOS application, right? So meaning I have now been empowered to actually also learn both platforms. So it accelerates also innovation. Lastly, this is understated, but create a pipeline. So we need conversions, right? From the Python code base, we generate a model. That model needs to be transformed into usable models for both Android and iOS, depending on which platform you want to support. Therefore, it makes everybody's life easier if we create a pipeline at the start. We put in effort for that pipeline. Once we now iterate and create new versions of our model, that pipeline will accelerate also our development. So with these three, we've managed to create and prototype some end-to-end AI models and deployed it to to an Android application, right? So, what are some of the deployment strategies for AI models? Just a show of hands, also. Who here has idea, or just general reaction for everybody? Just a like, thumbs up or thumbs down if you have used uh, mobile applications that needed to be updated, even games, right? There are ways to update mobile devices now. One is through the App Store, right? It's a full blown update for your application, but the rest would be over the air, right? It's very similar to models. One is you actually bundle your AI model together with your application build, or some will say it's side loading, right? You actually build the model, package it within the code base, the application project, and deploy it within the application build through the app stores or the Google Play Store, right? The next is over-the-air updates. One, content delivery networks would play a factor with this, and this is what we've seen with what mobile games, right? We've been downloading a few gig of updates per week for those mobile games, right? So similar to how to models, um, some models could be stripped down to just about 10 MB or yeah or less. We've seen models for some use cases that just be compiled to around 6 to 7 MB, right? But models will also actually explode in size to about a gig. So it depends now what use case you're really solving. So now over-the-air updates can still be used, but there should be some features that will adapt to your user experience, right? So it's really what a download page within your mobile application, if your user experience allows, and really a combination of both, right? So it depends now on the scope of the project or the use case you're trying to solve, but this could be also developed in phases, meaning within the, let's say, the POC stage, right? In the proof of concept, you don't need over-the-air updates. You just sideload every model to newer versions every time you want to test, and it's integrated within your pipeline, right? So with that, what are our factors, right, that we want to consider when we try to deploy an AI model, or even what plan to build or create features for our mobile application? One factor for us would really be the quantity and size. What do I mean by quantity? Or right, as I mentioned a few minutes ago, that we can actually have a combination of multiple layers of AI models depending on the acceptance criteria for the use case, right? So let's say we have 1 to 2 seconds processing time for the inference, that's acceptable. Multiple models can be built in within the pipeline, right? Next is actually how large are those files? What is the file size of that model? Next is actually the frequency of updates. In general, we can state this in two questions or two different ways. One is really how often do we need to update our models, right? But we can rephrase it now in a more analytical way with feedback, with a feedback mechanism if it is available to us. Until when will our models perform within the expected range and metrics, right? So it depends. For classification, are we seeing now unknowns within our classification, meaning our model doesn't recognize the newer objects? Uh, and that's what our user base and what feedback will tell us, right? So the factor really is how often do we need to update. Last, I guess, this I will tackle briefly on this for today's session, but really this is a whole new domain, right? Are we encrypting, let's say, our model? How do we protect our model, right? There are lots of ways to decrypt and unpackage mobile applications right now for one of the platforms, right? The other platform, it's harder, but it's still possible. But how do we now protect really our model? It's our IP, right? Next is actually how many variations. So I mentioned earlier variations, right? So this is in fact depending on the resource or the capacity of the device. So we can have different versions of variations of our model. We've seen out there tiny, the standard, the high res, right? So um, for everybody's context also, this means a model for high res, our high res model could be about 2 gig, right? The standard could be about, let's say, 500 MB, and the tiny could be just 50 MB. And that's just one model. But the trade-offs there are or is depending now on the performance. So the tiny could just be performing around 94%. Just an arbitrary number, but you've seen the pattern there. Okay. So um, with that said, I have my last poll. So I'm curious if you have tried deploying your own uh, AI models in. Okay, okay. We have a few answers. Okay, how much time will we need? Okay, okay. Okay. Thanks, guys. Thanks, everybody. Um, okay, entries are coming in. So say it. I'll wait for a few more seconds. Okay, there you go. Thank you, everyone. So, I guess based on this, for those who have tried, really, hopefully you've seen or you've gained some learnings from this. For everybody now, I guess we can take a look at this context. Who here has used this application? It's a utility application that translates for us. Who here has used Google Translate, right? Have you seen the latest version of it? There was an update a few hours, or I think it was yesterday. So, with everything I've discussed earlier, right? Um, sorry. With all that, actually, we have two ways, right? Um, Bundled AI models and over-the-air AI models, right? One really is now the object recognizer, the OCR part of this mobile application. And lastly, what? It has a built-in support for English, but the other languages can be downloaded. So this is one of the examples out there really that showcases this type of content delivery, right, for the AI models. But we've seen a few, but most probably they're silent deployments, right? They're silent updates. We have tried Photoshop for mobile, all the Adobe suite that is accessible for Mac, for Windows, for the Android and iOS platforms, right? So these are some use cases we can also look to when we want to create an end-to-end mobile application that has AI within it. So with that said, so here are some of the best practices or some practices we have seen that really help us. One, plan your application architecture. So architecting the mobile application right side of things with some support for infrastructure will base really on your project type. What do I mean by project type? Really, it's if you're trying to create a POC, you're trying to prototype an idea, if you want to pilot that idea, and if you want to push and deliver to production, there are different milestones that we need to hit, not just within the models or within the AI engine aspect of things, but within also the user experience for that. Why? User experience will also need to adapt depending on the capacity and the specs or parameters for our AI engine. So I've lumped everything within our AI models within the AI engine because really that AI engine will now power the features and use cases we're trying to solve with our mobile application, right? So depending on your, let's say we are still at the POC stage, we can do about with uh, go ahead and deploy or develop and deploy without the infrastructure support. But come prototype stage, we really need to have some content delivery network within our ecosystem, right? So therefore, that will now add to the complexity of development. How do we actually test it? How do we get feedback, right? How do we get live data? How do we sync it if our use case is offline? So really, one is in the planning stage, and planning can be can be diluted within sprints if you're following the agile methodology. So now, the development method that we are familiar with in the software development life cycle of software engineering can be also applied to AI and model development, but this is the caveat we've seen so far that we will also need to adapt the ceremonies and rules of Agile because some of the use cases that will need research from the AI side of things will not have readily available solutions. Therefore, we need to now adapt our development lifecycle within the AI and sync it up within the software side of things, right? Software development side of things. Next is actually I will not touch about the ethical concerns for this, but this tool really LLMs help accelerate and empower our engineers to solve cross language issues. Why? Before the advent of LLMs, right? Where do we actually go to? It's really the library of code, right? Stack Overflow. We ask, We punch in some keywords, we search for it in Google. Hopefully the use case is there. There is an available code that somebody answered, or we can ask ahead within Stack Overflow of our problem within our use case, right? But now with LLMs, we cannot jump directly to code, but we need to verify that code. But if that code works, it's good for us. We've actually now climbed over a hurdle that would previously take time to actually still communicate with our colleagues, right? If we have other engineers that are also full stack or more familiar with the tech stack, communication time and the communication process will still take time. Therefore, with the advent of LLMs now, every engineer is empowered to learn and develop for cross-language, right, solutions. Lastly, if you think math, this is just a joke, but math really is still with us. It's just abstracted, right? But for some platforms, math libraries are not available. So if we need to recode a math equation without that math library, LLM is one of your best friends right now, right? So I've seen some laughter for reactions. I think you've experienced them. Lastly, we cannot emphasize this. Uh, I'm not sure if you've heard about this. I'll coin an acronym, another interpretation for MVP, your minimum viable pipeline. Why, as engineers and developers, we need to really establish this to actually accelerate our development life cycle, and also to catch the mistakes we are creating. So right, to name a few, is really versioning. What model versions have we deployed, and what features are actually attached with that model version? So with a minimum viable pipeline, it could help our development lifecycle. Lastly, we will not talk about MLOps for this session, but there are a lot of sessions for MLOps. But we can see also that MLOps will really help us build our models, right? So with this integration, these three general categories or use cases or processes have really helped us with our development. And I think a look ahead. One, if you've seen from the previous slides or you've observed, there are really abstractions available now that also empower engineers that don't know AI, or see AI as a black box. Why? Uh, with LLMs, you still need to understand what that function actually does, right? What the math actually does and solve, right? But with abstraction layers like ML kits, it's it's a piece of code that you can use and integrate within your code base, right? It's really an input output function now. And just to emphasize, functional frameworks and SDKs and even APIs that are integratable to our code base is already what the future. Next is compatibility. I cannot emphasize the compatibility. Why? This removes our headache in terms of debugging and faster development, right? So part of these I've not to mention a few, but in MLflow, right, there are tools that allow us to see now if there are mismatches within the model versions. So model integrity, drift, those analysis for our models is really important to our pipeline. Lastly, with Onyx and emerging other ML bridge or the translators, right? So if you've heard about new programming languages or new ML languages that help us, so those are some of the initiatives that we see really that tackle this space. Lastly, I think it's really the support and the community. Apple right now has released a series, right? A series of documentations, code that allow us to use Core ML and integrate it fast with our other use cases with the use of Exode. But for Android, I think you've seen this out there in the wild. If you've seen it, there are model builders for us to use and utilize for retraining. But some really we need to put in effort to actually also build those pipeline. And with that said, I guess I'll open up the floor to questions.
Thank you so much, Sir Adrian Kayakaw, for that. Kayakaw, sir. Sir, sorry. Sir Adrian, thank you for that wonderful presentation. I think our participants have enjoyed it a lot. And there are actually a couple of questions posted on our Q&A tab. Let me read some of them. First question from Ryanel Maniego. What are some best practices you can share for integrating mobile AI models into existing applications?
Thanks for the question. So, if we take a step back and also recall, or I think I can move a few slides here. So, with the existing applications, right, you need to consider first your versions. Might it be Android or iOS? Um, so, for existing applications, one, you need to know where you can start modification, right? So what feature is it? Is it embedded within a bigger feature? So I believe we should start with assessments first with our features. Next, now we break it down and see if the use case um, is suited for it. Next, actually, is the testing part. So those are some of the few things I would like us to start with. Really, it's knowing um, the blast radius of the impact for the change we are integrating to our existing project. So that's the first. That's the key.
All right. Thank you, Sir Adrian. Rana, I hope that answered your question. Our next question from Sir Mark Anthony. How can we ensure robust testing for mobile AI systems?
Um, yeah, thank you for the question, Mark. I guess this will fall under the software side of things, right? But testing AI models is also another really big domain. But for this session, I'd like us to focus on the functional test, right? If you've heard about functional test, it's really what the use case we're trying to solve for classification. Can we really say that the model detects a cat or a dog or a person, right? Is the face detectable? I think these are some of the, let's say, focus, right? There are some incidents previously that a system allowed a monkey to be registered as an image. So I think those are some of the improvements. And really now for testing, we focus on the functional test based on the user story or the business case.
All right. Thank you, sir. We have another question from Sir Jeffrey Aborot. What are the strategies for gathering data in the field for measuring the performance of deployed AI models, comparing ground data with model inference?
Really for this, yeah, first of all, thank you for the question. So based on our experience, I can only tell, and from what I've seen out there, we need some sort of time and resource in order to accomplish this, backed with proper infrastructure and planning. Why? One thing is for our deployed models, we need to actually also format the metadata we want to extract and ship it back to our support infrastructure if it's possible, or we need to sync that data, right? So with that feedback and that mechanism, we can now leverage to actually iterate our model. But we also need to devote time and resource to actually execute it. Start small first with a, let's say, base data set or test set. Next is iterate over it until we actually are ready for prod release, or it goes the opposite ways, meaning we have so much data that we need now to process and create a pipeline for data ingestion. Hopefully
All
that
right.
summarizes and answers it.
Thank you, Sir Adrian. Another question here from Sir Kim John. Could you elaborate on the specific challenges and considerations in deploying custom trained AI models on mobile platforms?
Considerations. Okay. So I guess let's take uh, the classification problem. So sorry for the pun. It's a classic example for these types of right use cases for a classification problem. and how do we tackle confusion, right? Or newly integrated or newly introduced data to the system. So let's take, for example, a zoo. Our model, our classifier only knows cats, giraffes, what? Cats, giraffes, dogs, whatever that the animals in the zoo is. Once we actually now introduce another, what do you call this, another animal or another species, how do we know it's misclassified? So one challenge is really the sync up and to know the drift that or the our model is now performing subpar. Why? Let's say for a dog, another species was just introduced and it's now confused. It tagged it as a lion, right? So how do you detect that? So now it becomes a complex problem of software engineering and AI engineering, right? Because how do you now deliver that information back to the system that we are now what misdetecting? So it's both really a sync and sync with the software side of things. Really, it's the system integration already.
All right. Thank you, Sir Adrian. Next question from Sir Dex Manreza. How can offline deployment and cross-language solutions in mobile AI models benefit users in terms of accessibility and usability? And what are some potential use cases for these technologies?
Thank you for the question, Dex. Um, we've seen this in Hollywood and right mass media, K-pop, even sorry, K-dramas, not K-pop, K-dramas. So one particular K-drama showcased a utility app that actually helps in identifying objects and right and estimating and or giving information from their surroundings to that blind person, right? So that K-drama. So if you've seen it, yep. So if you've seen it, so an offline version, right, is really a powerful tool that will help not just here or not just in the cities, right, but it's really an empowering tool that can help everybody in the third world, more so in the third world, because right now what we've seen so far, right, infrastructure is not present in our country, in the Philippines. So more of the use cases we're tackling right now are offline. Therefore, if we have really um, deployments and a proper infrastructure system that we can now leverage on, we can start with building that and now expound it once infrastructure is already available.
All right. Thank you, sir. Um, we have another question from Sir Jeffrey Aborot again. Are there existing methods for compressing? Uh, where is that? Where's that question?
I believe compressing models.
Yes.
Yeah, there are. So, but to answer your question with a question, what are you willing to trade off, right? So, if we compress models, even in low power devices, not just mobile devices, right? So, Arduino, Raspberry Pi devices, those are ARM and low power devices. The trade off really is performance, is accuracy, right? So, what are you willing to trade off, right? There are techniques, right? You shave off the weights learned in between. There are techniques already available out there for in the let's say for computer vision and classification problems. There are ways to trim down, and that reduces the model size significantly. That's what I mentioned, 6 MB to 7 MB. But really now you're playing around with around 60 to 80% accuracies for classification problems, right?
All right.
But there are advances in the technology and the hardware for it. So I guess it's a matter of time. Also. But techniques are out there.
Okay. I hope that answered your question, Sir Jeffrey. Another question we have here from Gabrielle. What considerations should be made for resource constrained devices such as older smartphones or tablets when deploying AI models offline?
Yeah. Thank you for the question, Gabrielle. One for me, the first thing that comes to mind really is the support or the OS version, right? So once we know the OS version, we know what to work with, right? So it's what Android layer, Android 16, KitKat, right? So some frameworks are really not available for versions of lower versions of Android, right? So most recent Android versions, API layers for Android have now built in APIs or or even functions, right, that have already AI in it. But one is the OS version. Next is actually battery capacity, and to generalize, it's the compute power. Why? That will dictate how long you can use your application, right? How battery capacity is how long you can use your application or your tool for that certain use case. Next is actually inference time. Why? Inference time in low power devices tend to be longer. So I'm saying our real time could be defined, right, 2 seconds, but real time for low power devices can be 10 seconds, right? An inference process could spend more time in the processor in our CPUs than output as, let's say, a classification. But now that also cycles back to the battery capacity. So how long can our application be used? I guess that's one. Those are the considerations I think about when supporting low power devices.
Thank you for your answer, Sir Adrian. Next question we have from Sir JC. What strategies do you recommend from deployment challenges?
In general, I guess I will say first what is your project type, right? I'll go back to, is this a POC? Is this a prototype? Um, for prototypes and POCs, we can go and not yet develop the over-the-air updates. We can go with side loading our models, right? And if our environment is controlled, the team is just very lean, 1 to 2 developers. That's me and another engineer, right? So I'll stick with side loading my applications and faster testing time, right? But now when we introduce more resources, right, or more engineers to the team, we now need to strategize again how we will actually deploy our models and give our updates. So it's really starting with that and re-architecting as we go about the stages of our development phases.
Okay. I we have Sir JC again is asking a question, sir, but I think it's in relation to the previous question from Sir Gabriel. So, is it possible AI models to operate efficiently in scenarios with limited processing power, memory, or network connectivity?
It is very possible. So some advances even within the I think this is a branding strategy, right, for the brands, for specifically for Android, right? So it's built in already in the OS for I think analytics for the applications, even available in the API layer. So if we need to actually optimize, we need to gather more data, but tools are also there. But again, effort is really needed to um, extract that or even make that optimization, right? So it now is the balance of what do you want to develop and out get it out there, or what you want to optimize. Let's say for an existing, right, platform. Yeah? So those are the trade-offs. Yep, it's very possible.
All right. Thank you, sir. Another question here from Analo. What are the advantages and disadvantages for mobile AI systems?
Um, I guess one advantage would be really what I mentioned earlier is that uh, it solves our use case. It's targeted to solve our use case, and it's readily available on our hands. The disadvantage also comes with that there might be syncing problems later on, and or right a mismatch in terms of interpretation. It depends on the use case. It's case to case basis, but generally synchronization with right with the user base and the critical aspects of what we are trying to solve, right? If chances that there are critical systems that need to be synchronized, therefore some features will need to be put in place before we use it. So that is a disadvantage. Really, it's a complex system now. If we introduce offline, that now blows up to complex problems. I guess that's my take for it.
All right. Thank you, sir. And I think we're down to our last question from Ezekiel. Does existing LLMs require license or permission to the creators of it when you use it?
So I'm not an expert on the legal side of things. We can read upon it, but generally speaking, tools we use, right, for even this is the privacy in the privacy notices and in the disclaimers within the app use that these are generated. So I know it's a controversy, and right now, some really require for the use of the technology, right? So that's where license come in. But most of the tools we use, even open source right now, it's still licensed as open source. Therefore, we can or we need to also be cognizant of what tools we are using. So yeah, I guess for my point is there are some that we can use. There's some that really is open source. That this is the beauty, right, of the community. So I hope open source will still support, and everybody in the community will support open source.
All right, thank you, sir. Thank you once again, Sir Adrian Kayako, for answering all our participants' questions. Once again, guys, let's show our appreciation for Sir Adrian by showering him with emojis on screen. Thank you so much, Sir Adrian, and thank you to all of you for joining us in this afternoon's session. Before I let you go, I would like to remind you that we have, in fact, a leaderboard. So there's a trophy icon on the top right of your screens and on AirMeet. And so when you check that out, you will see who is leading the leaderboard. The top three leaders by the end of tomorrow will win some prizes. So I encourage everyone to participate, engage in every aspect of the platform, and enjoy the rest of the conference. Once again, thank you and good afternoon. See you in the next sessions.
Thank you.